Hi, this video will show you what a differential op-amp circuit is, how they work, and we'll go through some of their common uses. If you're unfamiliar with op-amps, I've done a variety of videos on them in the past, but there is a video on op-amp basics in the description. So this is a differential op-amp circuit. It has two inputs with two DC voltages of 5 volts and 10 volts respectively. The main purpose of this circuit is to work out the difference between these two voltage inputs and then amplify that difference as an output. As well as the supplies, there is an op-amp over here, as well as a selection of resistors and a voltmeter, so we can see what's happening on the output. If I now simulate the circuit, you can see we have 5 volts and 10 volts, and because the resistors are all the same, we get 10 minus 5 is 5 volts. So we're amplifying the difference. 10 minus 5 gives us 5 volts. If I change this one to say 3 volts, and this one to, let's say, 7 volts, so 7 minus 3 gives us 4 volts. The circuit also works with the supplies the other way around as well. So I do 7 volts and then 3 volts down here. We have 3 minus 7, which gives us minus 4 volts. Now it is possible to also amplify that output, and this can be done like so. If I change this resistor and this resistor down here, so this one to 2K and this one to 2K, so I'm doubling both their values. These are both 1K, these are both 2K. Instead of minus 4, we now get minus 8, so the output has doubled. If I now set them both to 3K, so 3K and then 3K, so these are both 1, these are triple the value of these two, we get minus 12 volts. So that's tripled. Minus 4 times 3 is minus 12. This behaviour might seem odd at first, so let's look at some calculations and try to prove it. We're trying to work out a relationship from the input to the output, so we're trying to work out how these resistors are involved. So we're going to make a selection of equations that allow us to connect the input with the output. So first of all, V plus, or the non-inverting input, because there is a resistor behind and in front of this terminal, we have a supply on one side, V1 on one side, and 0 volts on the other side. That means we have a potential divider. So we have V plus equals V1 times R2 over R1 plus R2. So that's R2 over R1 plus R2. Then we've got the general equation for gain. So voltage output is equal to the voltage on the terminal times gain. So I've written plus for each one. So it's the non-inverting output equals to the non-inverting input voltage times the non-inverting gain. The non-inverting gain is just 1 plus R4 over R3. I've done a video on non-inverting amplifiers before, but if you're not familiar, this is the standard equation for a non-inverting amplifier. Then we can combine these equations to get V out plus equals V1 brackets R2 over R1 plus R2, which is from up here. So this is our V plus. So V out plus equals V plus, or this section, multiplied by 1 plus R4 over R3. That's from over here. So we're doing V out times V plus times G plus. Now I want to work out the inverting input. So the standard formula for an inverting amplifier is gain or inverting gain equals minus R4 over R3. So we've got R4 over R3, and up here we've got V out equals V2 times gain. So that's just a general equation, output voltage equals voltage times gain. The reason we're using V2 here instead of V minus on this terminal is because it's inverting as shown here. We then take V out over here is equal to V2 times minus R4 over R3. So we're just putting V2 here and then negative gain, which is minus R4 over R3. Now what we want to get is a output equation for total V out. So that's V out total equals V out positive plus V out negative. Now this is quite a big equation down here, but it's simply this chunk here is added from the previous equation. This chunk is added from this equation. So we've got V out equals V out plus minus V out minus. You can see it there. However, a common technique to make this equation a bit simpler is to assume R1 and R3 are the same value and R2 and R4 are the same value. I haven't shown all the steps because it takes a while, but this is the final outcome. So we have V out equals R2 over R1 brackets V1 minus V2, or R4 over R3 brackets V1 minus V2. In this way you can sort of see how this becomes a differential amplifier. So we've got one input subtracted from the other, multiplied by the relationship of the resistors, as we just saw. This final equation is a more practical equation that you would use when designing your own differential amplifier, as it's much simpler. Differential amplifiers are also known as subtractors, as you subtract one input from the other, and they have many applications. But primarily they are used to remove noise, especially on twisted pair cables such as Ethernet or similar. Thanks for watching, be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!